Hello. Hello everyone. Just want to give you a brief introduction of the chess game that I designed based on multi-GPU processors. Um, yeah, so the basic design is to use at most 2 GPUs to play the game. So let me go to the main function here to give you like a introduction of the basic ideas and all the detailed setups of the design. All right. So basically, so first of all, you will need to check like how many devices you have. For example, I did this on my own computer and which only have one GPU. So here, if that is the case, so it will do a check. Okay. Yeah, of the number. I'm sorry. So for example, here, if there's only one that is less than two, it'll um, this single GPU emulation will be true, and in in here it'll just give you so that okay, the first device is device 0 and the next one will be also be 0 if this is true. However, if you have multi GPUs, it will use another one that is you will have a different number for this. Yeah, so basically that's the most important setup that it will need in the beginning. And then what I designed is that here I have a shared game state, which will record the basically the situation on the board and which side is about to play. You know, this information, and yeah, so this is also a core design of the program, and so you can see here the board. First, you can initialize it with the pieces are yeah. So I will give more information on this later. Yeah, then you just so you output something notifying that the game is beginning, and then this is the core design of how GPU is used in this program. That is, so I define something called player GPU context, which basically it is all the information for the player. So here each player is a GPU or the same GPU, or by you know in playing in turns. So here, let me show you the design of this thing. Oh yeah, let me first show you the share game state. This is much easy. Each is much easier. There's just a structure here with some core information of the board. That's not many things to talk about. The main thing is this one. This the player GPU context, because okay, first of all, it has like which device it is corresponding to, and also like which side is holding is either white or black. Yes, and it'll have some core functions. That is, you will you need initialize itself. Also, you need to have a function to destroy it after the game. And the main function that is it's called choose move. That is for this player. Okay, based on the board information situation right now, what move you want to choose. About the choosing logic, I will explain that later. So first of all, it will set the device and just copy the information onto the GPU, and then call the main kernel function to choose the move, and basically just to apply it to the shared game state, the board there, and yeah, and then just yeah. Of course, yeah. If there's no move to be found, it will notify the shared game that is the game over. So I'll explain it later. All right. Yeah. So basically, this is the design of the player who is about to play the game. You can see that after that, you will just use a thread. Use 2 threads for the 2 players, and to run the game together to let them play, and then you just start it. So after the game, you have this information showing you, okay, it's white wins or black wins or draw. Yeah. Okay. Or if it's not going, if this is going, it's not stop, then they will go to the default that is ongoing. Yeah. So okay. So let me then show you something about the core logic of like choosing moves. All right. So the way I use right now is like quite a simple one. That is, it just look at all the pieces on the board, and okay, I record all the moves that it can make. So collect all the possible potential moves and then just choose based on some evaluate algorithm. Yeah, so I will expand that later. Okay, so basically this is the function that generates all the moves. As you can see, iterate through all the board, that is the six cells on the board, and then if this P means the information, the state of that board. Say if P larger than 0 means here P larger than 0 means it is a white piece. If it's smaller than 0, it's a black piece, and equal to 0, that'll be a empty cell. So here, if they say okay, if the pieces are not consistent with the side that is playing right now, it will just stop. Yeah, and so right now, because this is just like a very simple design here, I only have pawns and kings for now. Yeah, so later I will add more pieces, or because it is an open access program, so I upload it to GitHub, so you can also contribute to the game for other pieces as well. Yeah, so this is just to make sure that the moves, the maximum count of the moves doesn't exceed there's a limit for the max moves, so that you have enough space on your GPU to store all the moves. Yeah, so yeah, this is just to apply the moves on the device, and choose. Yeah, this is the main function that choose the move. That is the kernel function. So basically, in the beginning, it uses thread ID 0 to it generates all the moves. So here I just give it a total maximum limit, that is there's a maximum 256 moves, and yeah, so you just make this shared memory for all the other threads to have access after that. And yeah, this is the main part. That is when for all the other threads, it will just so it will first get a temporary board that it copy from the device board, and then it apply the possible move that is generated earlier from here. And each thread will will apply one move, and then evaluate this evaluate this move. That is here. This the eval board simplest. This is a very simple evaluate function that I wrote. So anyway, it will get a score out of that. So and the score will be multiplied by the side, so that say okay, so for the white side, the higher is better, and then it's the same for the black side. So after you have all the scores stored here in scores, and then at last step also you use thread ID 0 to do a simple choosing algorithm. That is now it's just very simple. You just pick. Okay, so first is scores. It compares all the scores here, and then it chooses the moves with the highest score, and then out of the highest scores, it just randomly pick one move out of all the best the moves with the best scores. Yeah, so it picked with so I designed a little random function here for it to pick a move, and so if that is done, then it would just say okay, dfound equals 1. Yeah, so if there's no move, this will be 0. Yeah, so yeah, so all these will be stored in the device, and then after the kernel is called, the information will be then copied back to the host. Yeah, which is done here. Yeah, so I will just briefly let you go over the P's moves and the evaluate algorithm here, because these are not really related to the GPU. Is just some personal design of the game, so which is not very important. I'll just give an example for you. Like here, I only wrote pawns and kings. As I said, I only have these two for the game right now. You can maybe or you can add more in the future. Yeah, so it's very simple. You just use the board as a base, and then you would do some statement, if statement, say, okay, which side is this? You will choose the direction that it will move. The detail is just same with chess. As long as you know chess, you understand it pretty easily. Um, yeah, so like for example, in the beginning, you can move two two cells and 2,000 at one time, but normally you can only move one cell. Yeah, yeah, and then also because for pounds the capture is a little different, so it's mentioned here. So after all the moves, it's just a check, okay, whether that move is available. If it is, then it will add to all the potential moves in this array, all moves. Yeah, similar for the king. The king is a little bit more complicated than the pawn because it can move in all directions. So I marked it here. Yeah. So then let me go to the evaluate. Yeah, as you can see, it's pretty simple here because this is just to collect the total score of every piece on the board. Yeah, so I forgot to mention. So every piece have itself a value. So let me go to the main function here. It is a wrote. Oh no, no, it's in import. Yeah, here you can see that. Okay, so like for white and black, I would just use positive and negative numbers to mark their value. So say, okay, if you add up all of them, let's give you an example. If say this is a white move, okay, if it say it captures some of the blacks so that you lose some negative numbers, right, and then the total sum will be larger, which means that okay. At least for my algorithm right now, is that if whenever there's a kill, especially if you kill like queens or the king, it'll give you like a pretty highest value, so it'll be preferred to be chosen. This move, I mean, I think you can understand that. Yeah. By the way, there's I also designed something different from a regular chess. Is that so right now I just say okay, the king can be killed, the king can be captured, which is same with some Chinese chess. If you guys have information for that. But anyway, this is just for the simple design here. That's the king can be killed, so that after the king is killed, the game will be over. I didn't design like the like the real chess. That is, you have to design some kind of checkmate uh, algorithm, some judgment for that. But yeah, I haven't done that for now. But yeah, maybe I will update that later. Yeah. Um, yeah. So basically that's it. This is basically just to right now is to choose all the possible moves and then use some evaluate algorithm to pick the potential best move and apply that to the host. Yeah. Yeah, the bottom line is the game itself is not very complicated. I mean I'm not a game designer. It's just to uh, I just wanted to use this as an example to show okay how the GPU can be used in terms of simulating all this game, especially yeah, the key point of using GPU here is that it can is in this function, as I said, this yes, the kernel function that is for all the possible potential next moves. It'll activate a lot of different threads, all the threads in the GPU to calculate that, and that is, I think, best utilize the power of parallel programming for GPU. Yeah, as I said, I would actually this game is already uploaded to GitHub, and it's open access, so anyone can contribute to it. I mean, there's still a lot to do to make this game real. Yeah, so I hope yeah, if you're interested, you can just yeah, contribute to the game, and I'd be very happy to see you do it. Yeah, that's pretty much it. Of course, yeah, let me give you a little trial